Hello everybody, I'm the Draft Doctor, and today's layout is going to be an oblique cone. And we're going to use radial line development to lay out this because it's possible when our apex is within reach. So our fitting today is 8-inch round to 4-inch round transition that is offsetting 5 inches. Now what makes this cone oblique and makes it different from a centered cone is the fact that the center line is not 90 degrees to the baseline. This is a bit of an advanced bit of layout, so I've taken the liberty to get ahead of everybody a little bit here by doing some of the actual layout that is required ahead of time. Quite simply, I've laid out an accurate elevation view of my fitting. I have my 5-inch offset, I have my 8-inch height, 8-inch round, 4-inch round at the top. I've gone ahead and I've found my apex by extending the sides, and I have also put a profile on the bottom and used my radius to divide up that profile. So the tricky part with an oblique cone is to find the actual true length of the element lines as they lay on the fitting. Because it's not a centered cone, we cannot just rotate them over to the side. What we have to do with an oblique cone is kind of neat. First thing I'm going to do is I'm going to take my apex and I'm going to plumb it down to my baseline. Here's my baseline. So now what I've done in actuality is I've made a relationship between my element lines, which land on the baseline. This is a profile view, so it's a cut view of that round. And the apex now, which I've taken perpendicular to the baseline. So now in order for me to get the true length of my element lines, quite simply I'm going to take the perpendicular spot where my apex landed on the baseline. I'm going to bring it to the divisions on my profile, and I'm just going to swing that down to the baseline, and what that has done now is put it in its true length. And I'm going to do that for all of these. I'll swing this down to the baseline. And what I'm doing now is putting these all into their true lengths, and when I bring them back to the apex, it will also show where they intersect on the top. So my next step is to show these element lines as they relate to my apex, which is here. These element lines will now be in their actual true length and are located on the top and bottom rounds where they lie. So now, quite simply, what I need to do is start my radial line process. I'm going to swing arcs that represent all of these true lengths up into where my pattern development will happen. So let's start with the big end here. Hopefully my tool will make it. Okay. And there's my outside line. And I'm just going to bring this in. When we're doing radial line development, there's a couple things that we need to understand. First of all, if the apex is within reach, it is a preferred method simply because it's so much quicker than triangulating this fitting. And secondly, you want to make sure your tools are sharp. I sharpened up all my pencils before I did this layout. And the reason for this is because sometimes these radial lines get awful close to each other, and it's important that I can make a distinction between them. So there's all the radial lines that are going to represent the bottom. I'm going to shorten this up now, and I'm going to do the same from the top. Bear with me. When I pair these up in our layout, we'll notice that all I'm doing is transferring all of these true lengths into a pattern, and I'm spacing them out according to the 1/12 spacing that we'll be calculating right away. So there I have all my element lines. Now, we make a decision. I usually put the seam on the short side, which is here now. So that means this top element line is my start point. First of all, let's make a relationship with our apex. We need a start point. Well, I'm going to start from the top line here, and I'm going to finish at the top line here. There's my seam radial line, here's my seam radial line, and there now is my seam. Now, I have calculated a 1/12 spacing. We're just going to zoom out here first so you can see that, and we'll be able to see the pattern a little better. That should do it. I'll let that focus. So, my next step is to calculate a 1/12 spacing. Quite simply, I took the diameter, 8-inch round, times it by pi, divided it by 4, and I got 6.2832. Subtract 6 times 16 tells me it's 5/16. So I laid out a lines, parallel lines, 6 and 5/16 apart from each other. And then I used a rule, and I lined it up when I had 3 inches or a multiple of 3 on the diagonal. I marked each one. When I plumb it down to my stretch out at the bottom here, I now have my 1/12 spacing. All right. Next, I took my set of small dividers, and I've taken that 1/12 spacing to this point right here, and now I know I have that set. So here's how we do it. Now, each one of these lines represents the length of a radial line. Now what I need to do is have 1/12 spacing in between them. So I'm going to start at the seam, and what I'm going to do is just cross over to the next line down. Cross over to the next line down. These intersection points are the finished points of all my element lines in their true length. And I've hit the bottom, that's the midpoint. I'm going to work my way back up now. Okay, I've got the base. Next, I'm going to get myself a nice sharp 3H pencil, and I'm going to connect all these element lines to my apex. What this is going to do is going to create a grid at the top end of my layout here to give me my 4-inch round edge. I'm going to continue this all the way through the 12 spaces. There comes a point in our development as sheet metal tradesmen where layout is not as confusing as it once was, and it becomes a lot of fun, especially radial line. So here I have all my points, where they finish, on my 8-inch round end. And because I used my 1/12 spacing in between as I jumped across these radial lines, this is going to be the stretch out for my 8-inch round. So my next step is to get the top. Well, I've created a grid here, and I start at the top of the seam, and I'm just going to go 1 over, 1 down, over, down, over, down, over, down, over and down, and finally at the bottom in the midpoint I'm going to come up now, over and up, over and up, over and up, over and up, over and up. We have our fitting. Here's my seam at this end. Here is my 4-inch round edge. And here is my 8-inch round end. And that is a raw pattern using the oblique cone method of radial line development. I am the Draft Doctor. I hope this works for you. Don't be afraid to hit the like, hit the share. Until next time, bye-bye.